Okay, the job is already started, and you can see on the data flow, right? So there are two branches of this main job, right? So on the left side, you can see this is where we are accepting the main events. Right? So those all the main events from the patients, they are arriving in this branch. Once they arrive in here, we do two actions at this point. All the events are sent on to this other branch where the inference will actually take place. Okay, you see these calculate distances. This is actually the way we are calculating the anomalies or trying to find the anomalies. On the rest of this branch here, we are trying to count the events, and then based on the count, we will train the models and save the models. This is what we do in the rest of the stages here. Once the models are trained, uh, this branch here will actually load the models and will calculate the anomalies. At a point when there are no models, this is just a pass through, right? So whatever comes in will pass through. Now the job is already running, but you can see that there are no models in place at the moment. And what this means is there are no anomalies, right? So whatever events will come in, they will just pass through till the new models are trained. So I'm not sending any data at the moment. So we'll start the generator, and then we can look at the details again. So I'll pause the video, and we'll come back when the generator has started sending the data. So the generator has started. Um, it is sending, and this is 500 milliseconds, right? So it is sending two events per patient per second, right? So that means total 20 records per second we are sending from this generator. Let's look at the backend. Now, if I had queried them before, so there are two tables. One stores the models, another stores the raw data. Now, both are empty. Models, you will see that it is still empty because data might not have been collected so far. But this one, start now. I should do right. So the data has started arriving into the raw table. Now let's go and look at the logs for the job. So what you see here is, if I start from here, right? So it has collected the records for this particular patient ID. It has also collected the records for this patient ID. Now what happens next is that records for those patients, I mean this is just random I'm going through. So it will start reading the data from the Yukobyte database for a patient ID whose count has reached the threshold. Once that is done, it will be loaded to the BigQuery, right? So you can also see the events for where we are saying write to the BQ is completed. After the BQ is completed, we should see the events for training of models. So I'll just refresh, and I think it has yeah. So models were trained, and once the models are trained, models are fetched. Here you can see the models which were trained are now loaded into the memory for each of the jobs. And as soon as that is done, you can start seeing the anomalies, right? So these are the anomalies that we are detecting. I'll come back to the details of this one, but before that, let's go to the backend. First of all, if you look at the patient models, we see now that the models have been loaded, right? So these are the models which are trained, and these are the models which will be loaded and then referred to while calculating the anomalies. Now, another thing I'd like to show you is if we look at the data for the raw table, let's look at patient 7290, the first one itself, right? What you see in the last column here is this is for anomaly detection, right? If this value is too far away from the mean of this particular patient, um, then this value distance will be higher, right? That's how the k-means is working over here. Now what I've done is I've done a threshold of 3 for this distance to be identified as an anomaly, right? And then so whenever this distance, calculated distance, is greater than 3, that will be highlighted as an anomaly, right? So this is the anomaly which was detected, which was for a value of 154.4, and the base value, right? This is the mean value, that is the data that we're generating. The mean value was 134 for that patient, and that's why you see that 154 is highlighted. But you see that there is an anomaly detected for 129 as well, which is much lower. But in this case, the patient is different, and the base value for that patient is 111, which is lower, and that's why you see 129 is anomaly for this patient, whereas this will not be an anomaly for somebody who has a base of maybe let's say 130 or something, right? So this is how the system works. And another thing you can see is that there won't be too much of a delay in the system. If you look at a timestamp of the event, which is at 38 minutes 17 seconds, and if you look at the anomaly detection, it is 38 minutes and 26 seconds, right? So about 9 seconds here. And if you see some other, it will be similar. It is 40 minutes 26 seconds, and here it is 40 minutes 32 seconds, so about 6 seconds, right? And out of those 4 seconds is in the system itself, for the windowing that I have used, 2 seconds at each place.